Hey guys, I just want to point out another use for an LVDT. This is actually the coil. It's wound in a figure 8 for the secondary coil, and the primary coil is just wound around the perimeter. There's like 50 turns of each. At about, I think the gauge is about 28 gauge copper wire, and it goes to that 4-way connector. But like I said, the primary is wound all the way around the perimeter. The secondary is wound in a figure 8 pattern all the way around, and then it's just pushed together or wrapped together with a single-ended wire that doesn't come together as a close, so it doesn't complete a circuit, or anyway, it's enameled anyway, so it wouldn't cause a short. But anyway, it's just another configuration for an LVDT. This circuit converts the LVDT into PWM, and one of the reasons that I did this in this application was to control the intensity of a light. I've used this similar circuit in the past to do like non-contact foot pedals, but I can show you on the scope here. Let me back up so you can see everything. You can see this is basically just a piece of metal foil that I'm going to introduce over to one of the coils. But let me push this around here, and you can see the light comes on as I move it back and forth. As far as controlling the sensitivity, you can see the PWM on the scope as I slide back and forth. So one of the benefits of having this type of a sensor is, and the reason that I chose an LVDT type of sensor, because it is a differential transformer, it automatically has like temperature compensation. And actually today's a good day to do it, because right now in the barn that I'm in, it's about 30 degrees outside and just about as cold in the barn. So but anyway, it'll if the temperature changes, if it gets warmer, it'll track the temperature equally, so there won't be any kind of a drift or anything with this type of coil. And it works from either end. Let me switch hands here. It works from either end as far as introducing metal to the coil. It's a differential sensor, so you're creating an imbalance. So it's hard to see in the camera at the same time as far as what I'm doing. But as I approach the coil there, you can kind of see the light change there. And of course on this one, it does the same thing. You might have one side that's a little bit more sensitive than the other, but that's just because it's a hand-wound coil. But it works for this purpose pretty good. Like I said, for tracking temperature or anything like that, it's ideal. Because any kind of component variances or anything like that might be affected with temperature, it has a way of canceling that effect out. So anyway, I just wanted to show this this type of sensor and what you can do with a pretty simple circuit. I've got the schematic posted. This one's slightly modified on the output stage only. There's 2 transistors that are involved. The schematic only shows for like a 5-volt PWM. This takes it up to a 12-volt PWM, or whatever the voltage input is. It takes that to the full scale of the PWM output. It's basically just a transistor buffer in order to do that, but everything else is the same. There's a 5-volt regulator on there. It's a little this guy right here is just a TO92 case, 100 milliamp 5-volt regulator is all. And there's a decoupling capacitor across there, like 0.01 microfarad, as far as between the ground and the output. And that's really all that's necessary for this circuit. Anyway, have fun. Thanks.